Thank you very much to the organizers, to Dietmar, and to all responsible for giving me the opportunity to talk here. I'm really happy talking after Florian, because also my talk today has to do with part of his artistic practice in the wind channel. This contribution aims to give some idea of how marker materials which have been used in fluid dynamics research, mainly since the 19th century, are processed. What roles can be identified from the way they are applied? By chance, water and air, the two fluids of the greatest interest, are both transparent. In order to gain an initial insight into the flow pattern, scientists have to make visible the events occurring in the studied fluid. For this purpose, scholars have tested a variety of materials for use as markers. This list conceals, actually, that there exist elaborated recipes in order to cook the markers. And unfortunately, I haven't got time to elaborate on this here. With materials used as markers, in most cases, we are not only dealing with existing substances that are visible and have approximately the same density and viscosity of the liquid under study, but they also often fulfill other criteria and can serve multiple purposes that include the following: being, embodying, representing, and preparing an object of research, stabilizing an interface by carrying another marker, helping define visibility sections, working with both light and dark, so being photogenic or filmogenic, and being the base for further visualization. Although this list is far from exhaustive, it should suffice to make an argument for what the political theorist Jane Bennett calls think power. By this she means, and I quote, "the capacity of things not only to impede or block the will and designs of humans, but also to act as quasi-agents or forces with trajectories, propensities, or tendencies of their own," end of quote. Bennett seeks to complement structuralist approaches in the social sciences. I quote again, "The category of structure is ultimately unable to give the force of things its due. A structure can act only negatively as a constraint on human agency," and I'm coming back to that, "or passively as an enabling background or context for it." So she wants to strengthen the case for a positive view of vibrant matter and declares further, quote, "To the roles of context tool and constraint, or background resource and limit, I will add the role of actant." This term, adopted from the philosopher of science Bruno Latour, needs to be fleshed out and differentiated. Although the matters focused on here share the specific ability and purpose of making flows visible, they do so by adopting different roles. In historical case studies, it is nearly impossible to find out which elements formed ad hoc groupings additional to the experimental components and the setup mentioned in the publications and notes. But sometimes we might get the impression that this can be deduced from a series of publications of one group of researchers, as unexpected findings may lead to new research agendas. In the mid-1980s, a NASA laboratory in Notre Dame in Indiana investigated vortex breakdowns on a delta wing in a wind tunnel with the smoke streak method. On the left, the vortices are illuminated by a floodlight along the structure, and on the right by several orthogonal laser sheets. This is a typical impression they got. However, in some occasions, something else happened, and I quote them. "It is also interesting to note that when the smoke stream drifted away from the apex of the model, the smoke was sometimes entrained into the region in between the layers of the vortex sheet. Under these circumstances, the secondary structures appeared as dark areas, here they are white, void of smoke, but still identifiable by their outlines. The result is similar to viewing the negative of figure 4, and here I show figure 4. The fact that this occurs supports the conclusion that the observed structures are associated with the flow and not merely a consequence of the visualization method." End of quote. So the tracer's ability to produce an inverted image is taken as proof of it not affecting the actual air currents, which is interesting per se. But a second moment is important here. The scientists' attention was driven to regions where the smoke is absent. In later publications, this region was attributed a name, the so-called dark core region, which is clearly an artifactual notion, or better, a notion that came into being thanks to matter vibrating in a specific way, in order to speak with Bennett. Dark is where smoke plus light are not. Their ambition was then to tag, and I like the notions that they used, to tag only the core of each vortex with titanium tetrachloride. They then succeeded in seeding the dark region in the vortex with tracer particles by mapping out the flow field with a mobile tracer probe and thus determining where the fluid in the core of the vortices originates. They then could properly locate the marking ports. In this series of comparative photos, we see the result. So in the lower two photos. On the right side, with the more common kerosene smoke released somewhere upstream. On the left, the same situation with titanium tetrachloride smoke that was positioned on the determined specific spot on the model, targeting only the core. So with this example, we have already touched the various roles that markers adopt in fluid dynamics research. Here, it is first a kind of auto-validation or verification of its impactlessness in the intended sense, and second, the triggering of new research questions. Marker material is often fabricated and tested in complicated processes. As soon as the visualization method or the marker itself is under explicit investigation, something becomes a host fluid that is given a different name. In the case of dyes, it might be called solvent, or more generally, the working fluid. This indicates that marker materials are seen as objects of study. On another level, substances may be investigated with regard to their role as indicators of a flow, so the flow being the object of study, as opposed to being an embodiment of the flow. The former is the case in the 1989 research of Ismail Farhan and Francis McCabe, who wanted to determine the locations of flow separation and boundary layer transitions around high-speed trains. In this slide, we see that the air is enhanced with a whole front of tamed smoke streaks. The ideal line formation of the smoke streaks hints at the air current. In my view, this is in contrast to the way that Georg Wellner conducted his smoke studies on railway locomotives in the end of the 19th century. Wellner wanted to work out how trains and their chimneys should be constructed so as to minimize the inconvenience caused by the smoke entering the open windows of the train. I haven't found an adequate photo of the experiment, so I show an equivalent of the ship. In contrast to approaches where the smoke streak enhanced air front hits the train from the outside, in such a setup, and due to the way the smoke of the funnel is conceived, it is what is studied in terms of behavior, not of its characteristics as a marker. Thus, here it seems that the smoke is not only an indicator hinting at air, but it also embodies the untamed object of research. To put it another way, in this case, the investigated object exhibits qualities of a marker material while simultaneously sharing the location of its becoming. The German zoologist and hydrodynamic researcher Friedrich Alborn visualized and observed the processes on the water surface in his trough. To do this, he distributed fine-grained club moss spores on the surface of the water. Alborn's method of distributing the marker on the water provoked some debate. He was asked to what degree this was representative for processes in the interior of the water, as the surface tension has to be taken into account. Alborn replied that the clubmoss spores strewn onto the water served to cancel out tension of the water surface as with any other dust. In other words, in his view, the means to make flow visible simultaneously prepares the object of study in such a way that the natural surface can be seen as a conceptual section through the water volume. This is a second function lying in an unavoidable yet welcome side effect. The water surface has the big advantage of providing a privileged visual plane. It is obvious where to fix the camera's focus prior to the experiment. However, Alborn could not use the clubmoss spores in the form he got them from the shops, and I quote him. When scattering them on the water surface, it turned out that as soon as they touched the water, many of the fine spore balls made a dancing movement and surrounded themselves with a free perimeter of 1 to 3 centimeters in diameter. End of quote. In this way, the spores self-organized the distances to each other. However, Alborn envisioned a denser distribution and wanted the particles to commit themselves more to the movement of the water instead of bouncing on their self-generated dance floor. I quote Alborn here at length as he explains his troubleshooting process. By means of a careful extraction with alcohol, it is possible to remove the skin-building material. It involves not insignificant amounts of yellowish essential oils, which detached itself in the form of a dense emulsion as an addition to the water from the alcohol. Now the well-dried spores are no longer placed on the water by use of a shaker covered with a fine silk gauze, but by blowing them horizontally into the air with an atomizer nozzle about half a meter above the water, so that they hang in the air in the finest distribution, and when sinking down, they distribute themselves very equally over the surface without aggregating into flakes. In this way, one can easily attain a distribution of 4 to 6 spores on a square millimeter that proved to be especially suited for most purposes. Although the individual floating spores are hardly recognizable with the bare eye, with good lighting, they nonetheless deliver very clear flow images, which, with respect of resolution and sharpness, surpass all former records of flow lines by far. However, the observation of these images has to be carried out with a magnifying glass, or requires the prior magnification of the original photographs. As soon as the models are carried through the water, enhanced with swimming or floating particles, they cause the movements upon which the resistant values depend and which become visible through the viewing bodies. End of quote. However, these very delicate depictions are not suitable for reproduction in publications. They are just too fine. Alborn therefore suggests, first, covering the water surface evenly with spores, just as described, and then dividing this film by a small flat rod using gentle movements, and this clusters the spores into small flakes. In order for them to appear as white flow lines in the photographs, it is important that they leave areas of the same size free between them, so contrast is crucial. Alborn suggests blackening the background and using shavings or aluminum bronze, which is optically very effective because of its white metallic luster. He preferred lycopodium, however, as the aluminum shavings tended to cluster and stick to the experimental models. So from this we see that there is a clear sense of when such accumulations are welcome and when they are not. When the particles glue together, they are not always, but sometimes, ready or in the right formation. Even after they have been freed from their oil, they are perfect swimmers and can carry other material, thus stabilizing an interface between materials. In 1928, Alborn describes an experimental setup to study the phenomena of boundary transition. These notes attest another role given to the tiny lycopodium seeds. He seems to have divided the fluid of his open surface test tunnel into 3 sections. All were covered by the clubmoss spores, but one was also strewn with plaster flakes that provided sharply defined vectors. If the related photographs could be found, we would hopefully better understand the qualitative difference between the lycopodium and the plaster. Alborn is clear about why he uses both at the same time. The surface is sprinkled, I quote him, with the club mousse and thereupon plaster in fine flakes that would sink quickly without club mousse, while club mousse can be blown away from it, end of quote. In other words, club mousse spores stay with the water only in relative absence of the air movement, and whereas in an ideal case the marker particles would behave like the molecules of the studied fluid. This example makes clear that not every interaction with the marker results in their mimicking the behavior of the studied fluid. Thus, the task of the scientist could be reformulated as follows. How is it possible to turn a marker material into a visible water molecule and, moreover, into one that can be traced so that it provides its location at any time? According to the art historian Peter Geimer, a continuum of material represents an essential condition of the production of traces. They should be or deliver contact images without imprinting themselves to the waves they ride. But they would have no value if they would not leave any imprint on the camera sensors. This is a complicated connection between motion that should not be their own and visuality that is not the one of what is studied. But it is exactly the visual trace that is taken as a cue for the motion under investigation. As you may have noticed, I use various expressions for the materials added to the water and the air in these experiments, and so do the scientists. The most common words are tracer, marker, and indicator. It would be worth elaborating on the different connotations attached to these notions. Indicator seems to hint at something that could potentially be far off. Marker implies a direct contact, and at least in German, to trace means following something, and it seems to drag behind at least slightly. The remoteness can be sensed if we agree with the art historian Georges de Duberman that trace entails a structure of substitution, something is not there anymore, and if we consent with the semiotician Peirce, who defines the symptom as the paradigm of the index. Nonetheless, the tracer materials in fluid dynamics research seem to suggest closeness, spatially, but more urgently, also temporally. Indeed, they should show the processes on the fly in real time as they happen. So I Googled in order to find out something about the specificity of real-time tracing. Normally, I don't care too much about the automated suggestions, but this time I was really struck. Did you mean real-time tracking? Yes, probably I did. I had associated logging and tracking with machines, meaning hardware and software, and did not make the connection with the materials. However, with the philosopher of science Bernadette Bonson-Vincent, the difference might be leveled. In her article, Materials as Machines, she conveys a view of conceptual changes that occurred over the past 50 years in materials science. Since 1975, and due to the efforts to create sophisticated materials for space travel, the following is the case, according to her. The material is no longer a prerequisite imposing constraints on the process of design. So this is exactly the view that I initially mentioned that Bennett criticizes. Now, it is designed for specific performances, meaning the enslavement of the matter even got worse. In fact, chemical industries, especially designers of synthetic polymers, pioneered in the age of materials by design, because they experienced that actual materials are never meant to perform one single function. Rather, they have to perform a set of functions involving mechanical, thermal, electrical properties. Emphasis was put on performance, since they are tailored to a specific task in a specific environment. Now, I have to put aside that this clearly marks an even stronger friction to new materialism's flat ontology. Instead, I would like to argue that this situation was already given around 1900 onwards for the fluid dynamics research and for something that seemed much less high-tech, namely the imitation of hydrant aerodynamics. So my aim was to give a small taste of the first steps in a cascade of human matter-made facta leading to data. Markers are introduced, recorded, and further visualized. That may include whole grammars of recording or decoding systems. The obtained photographs and films await further procedures of tracking of the recorded spots. Here, using visual things is only the very first step in making things visible. I thank you for your attention.